Hello everybody and welcome. Today's video, our goal by the end is you should be able to see a system of equations and represent the solution graphically. So we're going to be looking at systems of equations and again solving for those graphically today. So to start off, grounding it as always in the real world, something that I'm sure a couple of us have seen thus far and will likely see more going in the future as well as you get a little bit older and maybe move out or don't have access to any like homeschool gyms, is that gym memberships are crazy. There's so many different pricing models, so many different options as well, and it's kind of hard to figure out which one's actually a good deal. So I picked two really common ones. So local YMCAs usually have a fitness center and a gym membership, and then also another one is Planet Fitness. I've also had both of these memberships over however many years, and some different pricing models depending on where you go for each of them. So for the YMCA, they did have a little bit more of a cost up front. So when I was doing it, it was $50 that you had to pay up front, and then plus an additional $10 a month. So if you were going to just do fitness for a short amount of time and then quit shortly thereafter, the $10 a month probably won't save you too much money because you have to pay all that up front. Planet Fitness, on the other hand, depending on the deals, but on like a standard day, I think it's like $20 to join. And then if you get the good membership that has access to everything on multiple locations, things like that, that is, I believe, $20 a month. So two different pricing models here. And we're going to use today's skill to go back and evaluate which one of these two gym memberships is the best deal for you. So there's our start. That's what we're going to ground it in, and we will come back to this slide after we go through the next few examples. All right, so first our definition. What are we talking about today? So systems of equations. When we're doing this, what this means is two or more equations that share variables. So basically we're talking about them in the same terms. If we were looking at the example I just talked about with the gym memberships, there's a startup fee and then there's a monthly fee. Those are both the same terms. It's not like one has a weekly fee, one has a yearly fee. Same terms, startup, and that's kind of the idea. A system, if we look at it on a graph, you would have two different equations and we would see that they come together. And the solution to a system is that point of intersection, but the system itself is just the fact that we have two equations that eventually come together. So first today, when we're just looking at these graphically, my advice would be to create a table and to plot the points for each equation so you can kind of clearly see where they are. You want to circle where they intersect. So like up here, they intersect there. So that would be an example of that. And then finally, you do need to write your answer. So write the value where the lines intersect. And that's going to be your final answer. So literally the ordered pair for this point up here, the x comma y, for that ordered pair, that's your solution. So a couple of different examples here, two different ways that you're going to see this. The first, you might have a quiz type question. It's asking like which ordered pair is a solution. So you'd have to go through that table and plug in and see, do both of these work? So for example, the first one, we would take it into both equations. So if we had x plus y equals 1, and we plug in 2 for x from that first ordered pair, and we plug in 3 for y from the second ordered pair, 5 does not equal 1. So we can automatically cancel out this ordered pair. That doesn't work for us. Let's go on to our next one here. So again, same equation, plug in 4, plug in -3, 4 minus 3, 1 does equal 1. So we're halfway there, but we still have to plug into the second equation. It has to work for both of them, not just one. So 2 times x minus -3 equals 11. So we get 8. And then 2 negatives give us a positive equals 11. So both of those work. So we know that this also works as well. And then let's check all three because it is possible we could have both coming in. So start off with that first equation again. And we don't want to be tripped up by 2 correct answers. 2 does not equal 1 though, so we can also eliminate that second ordered pair. So the big thing when you're checking these to evaluate for correctness is please make sure it works for both of your equations. All right, next, so a couple steps here when you're going through. For these, graph them first, see where they intersect, and then just make sure that the point where you're putting it actually makes sense and works. So what I would say for these ones here, I like to make tables, because sometimes when you graph, especially when it's like on a small piece of paper like this, the point where they intersect isn't always super clear. So for each equation, I like to start off by making a table and then plugging in some x values to see where we end up. So for our first equation here, if x equals 0, y also equals 0. If x equals 1, we have to plug this in, so we'd see that y equals 1 over 2. If x equals 2, y equals 1. And then if x equals 3, y equals 3 over 2. Okay, so let's go to our graph and plot these. So 0, 0, 1, 1/2, 2, 1. So we're seeing a pretty flat line right here. And we can trace off, continue with that same slope. So it's up 1 over 2 is what I'm using for my rise over run here. Okay, second equation, x plus y equals 6, or I make your life easier, y equals negative x plus 6. So 0, 1, 2, and 3 again. 0 equals 6, 1 equals 5, 2 equals 4. And if you're not sure what I'm doing here, I'm plugging in the x value as the negative x plus 6 to get, there's positive 3. Okay, so let's start off at 0, 6. I'll do this in a different color, actually. Go down 1, we go down 1 every time, go down 1 every time. So it looks like our point of intersection we just found is right here at x equals 4. So I'm going to double check to make sure if I drew sloppy lines, that could mess everything up. So plug in 4. That does give us a y value of 2. Plug in 4 for this one, and we'll get 4 divided by 2, which is also just 2. So that works. That's our solution. So the solution for this is 4, 2. So your job on the next one here is let's go through and let's graph both of these. I would say if you put it in y equals mx plus b form, your life is easier, but please make tables for these and make sure that in your table, the value that you're circling is actually correct, and it's not just a messy line there. Okay, so that's our skill for today. We're just looking at graphing. This is our intro day. We are going to be solving these algebraically soon, so doing some calculations and balancing. My ask is that even if you know those skills, to take a step back and make sure you're grounding yourself in the fundamentals of graphing today. So graphing is the way that we're doing it for today. I know there's other ways to do it. I'm asking us to use graphing as the way that we do it today, though. So back to Planet Fitness and the y. We can put these into y equals mx plus b equation. So 20 per month plus our starting point, our b value of 20. So we have a slope. And we could do that exact same thing that we just did. So 10 a month plus 50. So we could put both of these into some XY tables and put them onto graphs. So at month 0, if you don't work out and you just pay the starting fee, that's Planet Fitness. At month 1, it's 40. At month 2, it goes up by 20. So every single time we're paying an extra monthly fee. At the Y, however, our XY table, we start off and pay that fee of 50, but it's a little bit cheaper every month. We only go up by $10 per month in our total cost. And it looks like by that third month here, we found the point where we come together, where they're equal. So prior to that point, Planet Fitness is cheaper, but if you're gonna work out long-term, it looks like the Y is a better deal. So at month 3, we have the same cost at month 3. So that solves it for us. If you're gonna work out for more than 3 months, definitely do the Y. If you're only gonna work out for 3 months or less, looks like Planet Fitness is a good deal for you. All right, so there is our system of equations video. We're solving by graphing today. Any questions, let me know, and I will see you all in class very soon. Thanks for watching.